To everyone watching this video, I'm Mr. Ish. Thank you for joining me. We're looking here at a single comprehensive example, extreme value practice question, where we put everything we've learned in the previous two videos regarding the relative and the absolute maximum, minimum, the extreme values, critical points, all of that to work. We have a function f of t is equal to t cubed minus 12t plus 4. Interval is there. You know what you have to do, so let's get to it. The first order derivative is what we'll look at. And here we will have a 3t squared minus 12. We can do a second order derivative. The first order derivative will help you determine the critical points. The second order derivative will help you designate anything as being relative or locally maximum, locally minimum. Here it will be 6t. You take this equation here and you equal it to a 0 and see what happens. You can isolate 3 and you'll get here t squared minus 4, and then you will have 3 into t minus 2 and t plus 2. T is equal to 2 comma minus 2. So I'm seeing a minus 2 and 2 as additional critical points which are coming about. I have 4 points, 2 of which are endpoints and 2 of which are critical points I've determined. If I put them in order, I'm looking at minus 3, minus 2, 2 and 5. I want to focus here first on these two and see what happens, because they're not endpoints. They might very well be relative maximum, relative minimum, and I'll put them with regards to this. When I do a minus 2 here in the second order derivative, I'm getting a 6 times minus 2, I'm getting a minus value, so I'm seeing here a relative maximum come about. When I'm doing in the second order derivative that, I'm doing a 6 times 2, I'm getting a positive value, and this positive value indicates that I'm looking at a relative minimum. This seemingly appears to be relative minimum, and this seemingly appears to be relative maximum at the values that you see. But I want to put everything in here to see what exactly is true, what is not, absolute or not. And I'll do everything here in order: f of 5, f of 2, f of minus 2, and f of minus 3 in your original function. When you put f of 5, you get a pretty large number, 69. When you put f of 2, you get here a minus 12. When you put f of minus 2, you get here a positive 20. When you put f of minus 3, you end up getting here a 13. Now look what happens. What was originally being designated here, f of 2, where we had a 2 as our critical point value, right here 2, what was originally being designated as a relative minimum may now certainly end up being an absolute minimum, because from all of these range values it ends up being the lowest. F of 5, the endpoint 5, is generating me an absolute maximum. So this 2, the critical value 2, can no longer be regarded as a relative minimum. Within a local region, even more focused than that, it can be a relative minimum, but over that entire interval it becomes an absolute minimum. And I'm talking here about this 2, the critical value 2. What about this critical value minus 2? Minus 2 ends up being, as we saw over here, a relative maximum. It's a relative max. We know that to be the case. How about f of this minus 3? What about this minus 3, this endpoint right here? It ends up being no designation, because the only designation an endpoint can be is either a no designation or an absolute maximum, absolute minimum. But the absolute maximum, absolute minimum over that interval has already been taken, and it's certainly an endpoint cannot be a relative max, relative minimum, because you evaluate it on both sides. For an endpoint, you have only one side being evaluated, not both, so it receives no designation. So this stands. At an x-axis value of a 5, we have an absolute max. That's good, and I'm happy with that. At an x-axis value of a 2, what was originally thought to be a relative minimum is really an absolute minimum. And at an x-axis value, which was our critical value we determined, of minus 2, we see a relative max, because here we're determining a negative. Because where you have a relative max, you'll see some sort of concavity which is pointing downwards, but you have positive tangent lines converting to 0 to minus. You have a conversion from positive to minus, so that clearly indicates it as a relative max. And there's no relative minimum in here. We have 3 designations as you see them, and that's it. This gets designated as nothing. The endpoint does not get designated as anything other than an endpoint. And there it is. The question has been solved for you. The finer point here was this right over here, and another finer point is that this value of 2, x-axis value 2, a critical value, in a very narrow area it is a relative minimum, but over the entire interval it is an absolute minimum, as you see right here. Thank you for watching. Have a nice day.